Okay guys, I changed the layout of that. Sometimes you use this thing, this design idea thing, and it just cuts out some of the material that you need. Okay, right. So again, very similar to what we're doing, where I think the question wants you to, there's a couple of things, but ultimately we need to find out what the actual life cycle cost is before we can actually make any decisions. So let's actually work that out. Again, it's a routine of everything we've been doing so far. We have the number of units. We want to find out what the average cost is over the life. We have here 10,000 units being made here, 12,000, 11,100, and we have all of that. So what do we have here? So we have production costs per console. Here we are. Here we have this. We have this. We have this. We have this. I mean, this is production and that's the warranty. Might as well just do them together, right? Make my life easier, and so my calculations are easier. Then I just add all these together. That's what I'm doing. So I'm just going to put 480 here, so I'm not double calculating. It's just all because of time. So this is 330, isn't it? And this is 290 plus 495. 290 plus 45 is 335. 335. Great stuff. So what do I have here? So so let's just do the calculation, right? So I'm just going to calculate the production costs first and then just tag all these on, but I'll put all my workings here on the side so we can just add it all together. So 480,000. So 480 times 10 there. So we have 480, then we have a 0, then we have 3 zeros, 2, 3. So we have that. So we have 4.8 million, right? And that's that. Tick for those two. Then I have 460 times 12,000. 460 is 460 times 12,000. So here I have 5, 2, 0, 0, 0, 0. Then here I have 330 times 11,100, right? Because that's what's going on over here between these two. And I have here 3,663,000, and here I have 335 times 3,000. So here I have 1,005,000. Great. So those are all my production and warranty costs done. Then I now have my R&D. Chuck that in, 950,000. Then I have my marketing costs, chuck that in. I have 230 plus 120 plus 20 plus 5, and let's add all that together. 230 plus 120 plus 20 plus 5. That's 375. Right, and I think we have, yes, the end of life cost of 125,000. So add all these people together. So we have 4.8 million. Careful with all those zeros. That's always what tends to trip me. 5,520,000 plus 3,663,000 plus 1,005,000 plus 950,000 plus 375,000 plus 125,000. So I have a whopping 16,438,000. Excellent. And how many units are we making? We are making 10 plus 12 plus 11,100, blah, blah, blah. So 10,000 plus 12,000 plus 11,100 plus 3,000. And that's 36,100. So we're making 36,100 units. So let's just do that. Multiply that times, divide these two together, divide the 16 million by the 36, right? 36,100 times 16,438,000. So you come to a total of £455.34. That's the life cycle cost. And currently, market research shows that customers are willing to pay an average price of 420. So, I mean, if you do it correctly, it's worth the time because you will get the answer. So it says the cost of the console calculated the using is higher than what customers are prepared to pay. We can see that's very correct. And typically, if you spend time on R&D, you do end up reducing the warranty cost later on. So the answer here is D. Both answers are correct. Right, so let's look at this very quickly, and let's see. It says if we use a drag and drop, just to sort of understand what the benefits are of life cycle costing. And because, again, like I say, life cycle costing tends to look at the entire span of the product over its life, that's a fair assumption. It does provide a true, because of course we're looking at the entire period as opposed to just looking at it in annual terms. That's the first. Those are some of the benefits. The length of the life cycle can be shortened. In terms of being a benefit, this isn't typically a benefit. You're ultimately trying to extend this product for as long as you can to make as much money as you can, right? I mean, this is very much a business strategy. So I would argue that no, that's not typically a benefit. It's just unfortunate that sometimes you have to, but it's not a benefit. If you could leave the product there forever, becoming literally going through the product life cycle, right? So where you avoid decline. You just mature and stay at that point and make money, if you like. Expensive errors can be avoided. Yes, if we spend time initially, if you like, at the beginning, and you can work, if you like, towards the end in the decline phase to make sure you're avoiding costs. So typically I would give this one as well. Definitely lower costs definitely can be achieved earlier if you're designing out costs. And because it's over the life of the product, you can work through, if you like, of managing your selling price, because really we're talking about marginal costing here and marginal pricing, so this is feasible as well. Decline stages of life cycle can be avoided. I thought this was a tricky one. I mean, I would say, or just when you look at it, you can't avoid it. You can only continue to see, but I guess the truth is that every product does have its day. So at some point, I just don't think this is for manufacturing probably, but overall in life, some products just evolve and adapt a little, and we can keep seeing, if you like, adaptations to a particular product that people keep using forever and ever. So I think I'd probably just say, to be strict, I would say yes, that this is not possible. Decline stages can't be avoided. Sorry, when I say yes, I mean you can't avoid it. Every product must come to its natural end. Right, so I'd have gone for this one, this one, this one, this one. This one, I think maybe at a higher level is debatable, but there you go. Good, another written one. Oops, sorry, this is missing out material. Let me just change the design. Change the design here to make it so we can see what the actual question was. Oops, sorry. Okay, yeah, so that's asking for 1, 2, 3, and 4. At least we know what they're asking for. Okay, great. So which of the following is true regarding the justification of the life cycle? Product life cycles are becoming short. This means that, yes, so this is important. The initial cost being an important component is true. They are becoming shorter. Think about tech. Product life cycles are increasingly weighted to the start. Yes, it's important. This is, I think I'm sure I saw 90% of the costs happen right at the beginning, 90 to 95%, 90% actually. They argue of all the research and, if you like, research and development and the marketing and all those big costs just to launch this product. Although a lot of that happens right at the beginning. The high costs of this necessitates a high initial. Well, necessitates, I think, is just what maybe kills this here. Not really, no, because we're really trying to match. I'm gonna think of like accrual accounting. We're trying to map the costs and gauge the price through its cycle, through introduction to maturity and growth. So that's more the task, as opposed to saying we're going to slap on a high price. That's not the point. It's not the high cost that necessitate that. It's maybe looking at the market and seeing what marketing strategy you want to go with, but not due to the costs. Costs are very much about matching. So this one doesn't work. It's slightly sneaky, but you're trying to, I think this gives it away. This necessitates. It doesn't necessitate. It makes it assumes that that's the system we're going to use. You might actually use penetration pricing just to get in and then grow. So therefore, if you're using penetration pricing, that's actually a lower initial selling price. Traditional capital budgeting techniques, which are kind of our year-on-year kind of approach, do not attempt to minimize or maximize. And that's sort of true, you see, because typically we would just look at things on a year-by-year basis. So the life cycle costing is probably the only one that says let's look at the entire life of what's going on. So the answer here is 1, 2, 1, 2, and 4. Right, almost there. Which of the following statements is true regarding life cycle costing? Life cycle costing takes into account all costs. That was true up to there. Except sunk costs? No, it takes those into consideration as well. You've seen us do that so far. We always add those costs in. So this unfortunately isn't true. We are interested in the life of the product. That's the key point. And we're trying to ensure we generate a profit over the life. So that's correct. Life cycle costing is most useful for products with an even weighting over their life. Nah. It says most useful. That's not true. The whole point is spreading the costs. So even when we have products that aren't even weighted, we're still rational because they might cost a lot at the beginning, but a little in the end. We're looking for an average. So 3 unfortunately doesn't work, which gives you just 2 only. Oh, sorry. The last question, let's look at it. Let's go to it in the book because we're here now. Is 54. So company B, let me just snippet it out. Sorry, let's snippet that out very quickly and bring that into the PowerPoint so we can play with it. Actually, we can just work on it here. Okay, great. So will it let me do it? Let's see. Oh, yes, it is. Excellent. It's blue color this time. Company B is start developing a new product for launch in its existing market. It has forecast sales of 20,000 units. Okay, thank you very much. 20,000 units. And marketing suggests a selling price of 43. The company seeks to make a markup of 40%, a markup of 40% product cost. So let's get the product cost and see what we have here. So you have design cost of 43,000. Okay, thank you very much. I'll write 43,000 here. Manufacturing cost of £15 a unit. So I'm going to go 20 plus 20,000 times 15, which is equal to 30,000. So I have the 43,000, I have the 30,000, and then I have decommissioning costs of 30,000 as well. So I have all these three costs together, and here we are. So the company estimates that if it were to spend an additional 15,000 on design, manufacturing costs could be reduced. It's an interesting one. It doesn't give us any actual way by how much we would reduce it. This is a future cost as well. You haven't spent it. I wouldn't include that 15. I'd leave that out. It's a future cost, so you can't include future costs in the cost of a product, right? So adding 43, 30, and so that's 73. 73 plus 30 is 103. So 103,000 here. Actually, careful, Oyen. 15 times 20,000 times 15. Let me just get that right. 20,000 times 15 is actually 300,000. So yeah, almost missed that there. That's 300,000. I just noticed it just seemed a bit small. 43,000 plus 30,000 it comes to 43,000 plus 30,000 is 373,000. So you have 373,000 divided by 20,000 units. Divided by 20,000 units comes to £18.65. So you have £18.65. That's your life cycle cost. And so the company seeks to make a markup of 40% product cost. If I multiply this times 1.4, that's 26. So I can sell it for £26.11. That's your markup. That's the markup you're looking for. People are wanting to. So that's fine. That's what you can sell it for. This question is just asking for the cost. So the cost is £18.65. So if the question had pushed us further, yeah, this 43 is a lot. I mean, that's too much probably. You can do it for £26.11 and you're fine, because that's a markup of 40% on the original cost. Cool, great stuff, guys. Awesome. So I'll see you at the next set of questions.